So in section 3.3, we talk about different properties of functions. So in other words, now that we can identify when a graph is a function or when an equation is a function, let's talk about specific properties that we deal with on functions. So hopefully you printed the handout, because you really need to read through the front page before you ever start the video. So what I recommend you doing is pause it, go look at it, and then come back and take a look with me. So the first thing we're going to talk about is something called increasing and decreasing functions, which is really important from a calculus point of view. So in other words, if you're running a business, it'd be nice to know if the profit is increasing, your labor costs are decreasing, those kinds of things. So we're going to take a look at our three different pictures. It's important to recognize a couple of things. When we talk about functions in general, we always move left to right. So please remember that we're looking at the graph as we move from left to right. Always, always important, so that we all do it the same way. So when we take a look at the first picture, if we were a little itty bitty bug, pick your favorite bug, I always like to be a ladybug, and you were walking along this curve, wouldn't you be walking uphill? So we all agree that we're walking uphill for this picture. If I'm walking along this picture from left to right, and I'm walking downhill. And finally, on the last picture, if we're walking along it, we're not walking up or down, we're walking flat. So this would be kind of flat. So in terms of mathematics, what that translates into is you're going uphill. It means that it is increasing as you're going from left to right. And it's increasing along the x values. So it's increasing along the x values. So for this particular picture, you'd be increasing from x1 to x2. So notice we're writing in with the x values. For our next picture, we would be decreasing because it's going downhill along those x values again. So this one would be decreasing from x1 to x2. And again, they're open parentheses because it's an open interval with open circles. Regardless, when we talk about increasing and decreasing, it's always along an open interval, because if you stop at a point, you're not increasing or decreasing, you're stopped. So that's why we always use parentheses when we're writing these intervals. And finally, the last one is constant. The graph is level. It's constant along those x values. So this one would be constant from x1 to x2. Important that you note somewhere in big bold letters or words is that we always write these always. Use x values for the intervals. We already know what y is doing. Y is the value that's either increasing or decreasing or remaining constant. So that's already answered. So you need to know where it's happening along those x values. Another concept that we talk about in terms of properties of functions are maximums and minimums. And again, I don't want you to make this too complicated. The math speak is on the handout. We're going to look at this from more of a layman's point of view. So when I look at these two pictures, we all agree that this picture has a top to it, a hilltop, a peak. So the maximum occurs at this peak. So this peak is called the maximum. It is within a local interval, so within a specific area of the graph, a specific slice of the graph, this is the top value. Over here, when we take a look at this one, within a specific slice of the graph, within a localized piece, this guy, our trough, is going to be our minimum. Now, I like to record those maximums and minimums in terms of a point. Your textbook in the online homework very specifically talks about the maximum as the y value and where it occurs in terms of x. Where it occurs on x. Same thing with the minimum. It talks about that minimum being the minimum y value and where it occurs in terms of x. Occurs in x. So you might say that the maximum is 5 at x equals 2, assuming that this is the point 2, 5. And that's the online homework and the way it records that information. I'm okay if you just tell me that the maximum is at 2, 5, but since you're doing online homework and online exams, you're kind of stuck with that. So. Okay, and those are the different properties that functions have. So what we're going to do next is we're going to take a look at one specific picture. It's on the handout, but in order to answer the questions, we all need to agree on certain points along this graph. So the graph looks something like this. Nice, pretty curve. And we will eventually graph things like this in chapter 5. We're not there yet, but we will get there. And specifically, we need the intercepts and those peaks and troughs so we can talk about it. So reading the picture, and it's a difficult picture to read. I didn't copy as well as I wanted. We're going to call that -4, -10. We're going to call this point over here -5, 0. This one over here, we're going to say is at -1, 0. This point up here, and I need to be careful because my picture's not quite good enough here. The graph actually crosses the y-axis and continues to go up before it comes down. So this point right here, we're going to label as 0, 4. This point up here, we're going to say is 1, 5. And then finally, this point over here is 4, 0. And I think that's everything. So take your hand out, label those points, it makes it a lot easier on us. So we're going to use this picture and answer a bunch of questions about it. And some of these are old questions. We asked these in the last section, so they should be comfortable. The very first thing that I asked for is the domain. Again, a reminder is always left to right. The domain is the set of x values we're using. So in terms of x's, these arrows on the end are telling me that it's going out as it continues to go up. So our domain is from -infinity to infinity. Question B asks for the range. The range, if you remember, is our y values. That's the bottom of the graph to the top of the graph. Well, in terms of y values, the bottom of the graph is over here at -10. It is a point on the graph, so we're going to put a bracket on it. It's included. The top of the graph is the arrows. So this thing continues to go up, so we'll call that up there at infinity. Okay. The next thing to ask for are the intercepts. So our intercepts in terms of the x-intercepts are at -5, 0, -1, 0, and then again at 4, 0. It's got 3 of them. It can have many of them, as many as it has. The y-intercept is up there at 0, 4. Again, only one y-intercept makes it a function because if it wraps back to that y-axis, it's not a function because it would fail the vertical line test. Okay, now we come to the new stuff. So the new stuff is where is it increasing? So we're looking for the increasing intervals. We're also going to look for the decreasing intervals. And then we're going to look for where it's constant. Well, when I take a quick look at this picture, is it constant anywhere? Do you see any flat pieces to my picture as we move from left to right? I don't. So there are none, and I'm just going to say none right off the bat on that. Okay. So I like to do the increasing and decreasing all at the same time and just walk along the graph from the left side to the right side. So I'm over here on the left side. If I start walking along this left side, I'm walking downhill. And I'm walking downhill all the way until I hit an x value of -4. So that's decreasing. So it's decreasing from -infinity to -4. Well, then at -4, I start walking uphill. So now it's increasing. It's walking all the way uphill until I hit an x value of 1. So I'm walking uphill from an x value of -4 to an x value of +1. But then unfortunately, we start changing direction again. Now we're walking downhill, and we walk downhill until we get an x value of 4. So from 1 to 4. And then at 4, we start walking back uphill again. In terms of those x values, we're going uphill. So 4 to infinity. So what should happen is one endpoint becomes the beginning of the next interval. That endpoint becomes the beginning of the next interval, and that endpoint becomes the beginning of the next interval. So you should be able to walk along the graph along those intervals. And again, x values only. Now, G asks for the local maximum. So that means within a specific area, where's the highest or the peak of the graphs? Well, for us, we have a peak sitting right here at 1, 5. So notice that there is no absolute maximum because the graph continues to go up here. It's going to continue going up. So we have no absolute one. We just have this local one in terms of here. What about a local minimum? Well, it has 2. So if I take 2 different open intervals, I'm going to center one of them over here. Sure enough, this is the lowest point on the graph in that area. So -4, -2, that slice of the picture. And over here, we have another minimum, another trough. So at +4, So it has one local maximum, but two local